All right, let's do a quick little video here on completing the square. There's lots of different ways to do the completing the square method. I like to go through the graphing form first. It helps us graph the parabolas, and it's actually pretty easy to do if you want to put it back in standard form, we can do that pretty easily too. Conceptually, this is what's going on. If I have this equation, y equals x squared plus 8x plus 10, and I physically build a square out of tiles. So this is an equation mat. I have the y over here. I have the x squared plus 8x's and then 10 unit tiles. I could almost make a square, but I'm short by this many. So I'd have to go 1, 2, 3, 4, 5, 6 more. 6 more unit tiles would have to go in here to make a complete square. Okay, so since I'm adding 6 on the right side, if I physically built it, that I'd have to add 6 on the left side also to keep the balance. Well, now the area over here can be written as x plus 4 quantity squared, and I still have y plus 6 on this side. So I'd have, I'll just write right here, y plus 6 equals the x plus 4 squared. And it's already almost in graphing form. If I just put the 6 to the other side, I'll have graphing form. So y equals the x plus 4 squared minus 6. Now, it'd be very easy to find the vertex if I wanted to graph this. And the y-intercept, I could probably get the easiest just from looking at the last number in the original form. If I plug in 0 for x here, I get my y-intercept of 10. So I could draw a quick little sketch. There's 10, -4, -6, roughly speaking. And without even knowing the x-intercepts, I could just do a rough sketch here. Now, I couldn't do that. The reason we're doing this is because I can't factor this. I can't factor like x here and x, two things that multiply give me 10, like 5 and 2, or 10 and 1. To get, when I do the smiley face thing, I can't get 8 in the middle. So that's not going to work. So this is a nice quick method to figure this out. Now, if I did want it back in standard form, I could just take this and multiply it out. X squared plus 8x plus 16. Nice, what the heck is that? Plus 16, and then minus this 6. So x squared plus 8x plus 10. And we can double check that we got the same thing, where we came from. So it works. So let's do another one. Now, instead of having to build it and say, well, I was 6 short here, there's got to be another way so we don't have to like build it or draw it all out. And it actually is pretty simple. Just kind of ignore the 29 for now. And just look at this part of it. So we have x squared plus 10x plus something. Okay, to be our complete the square here. So we're trying to make a perfect square trinomial. Well, when we do the perfect square trinomial, we know that this middle term is twice the product of these two terms. So we'll basically just take half of it to come up with this part of it. And we're almost done. And then if you multiply this out, you get x squared plus 10x plus 25. Okay, but I don't want 25. I'm supposed to get to 29. So what's wrong is, well, I'm 4 short. So if I just simply add 4 to this 25 here, I'll get back to where I should be at the 29. So this should be equal to the original. And I could multiply it all out. I get this, and I have plus 4. And if I can simplify it, I'll get the original problem. All right. So let's do another one. I have x squared. I'm sorry. Get rid of that. Just x plus 3 squared. That takes care of this part. Plus something or minus something. Now, instead of writing it all out, I'm just going to worry about that just to kind of save some time. I know that the last term is 9. I know I need to get to the -2. Algebraically, you could just do -2 minus 9 to get the answer. Or you can just think in your head, if I'm at 9 now, way up high here, I need to get down to -2 down here. I need to go down 11 spots. So I'm just going to go minus 11. Okay. So whether just take this number minus that number that you ended up with to come up with the difference, or you just want to do it in your head, that's fine too. All right, just a couple more to go. What if there's a subtraction? It works the same way. Okay, go ahead and pause it if you want to try it on your own. That's what I'd suggest. But I'll get y equals x minus 6, because I'm taking half of that 12, squared. I just square this last part. It's going to be positive always, so 36. And then 30 minus 36 is -6. Oops. Or just think, what's the I need to get from 36 down to 30, so I need to subtract 6. Pretty cool. Moving on. What if this is, I think this is my last problem, isn't it? Yes. If this is not a nice even number, it still works. You can just still follow the same rule. So plus 2.5 in this case, squared. Now 2.5 squared, you might need your calculator for that. But 25 squared is 625, so it's going to be 6.25. And I need to go from 6.25 down to negative 4, so I'm going down 6.25 and another 4, so I'm going down 10.25. Or simply do negative 4 minus 6.25. That gives me the last number. And again, if I want to graph these, that's why this is so handy. My vertex is at negative 2.5, negative 10.25. It's always the opposite of this in here, and it is this over here. And my y-intercept is going to be negative 4. Don't use the negative 10 for y-intercept. It's back in the standard form as the last number. Or if you want to do the long way, plug in 0 here, multiply it all out, you'll eventually get to negative 4. All right,